section 2.6, this is an extension that goes along with what we were talking about in the last video, which was on point slope form. And in this video, we're going to recall a few things. First off, we need to recall what parallel lines are. The parallel lines are lines that basically have the same slope. And we need to understand that perpendicular lines have slopes that when we multiply them, they equal -1. And I'm going to give you a little bit of a hint with that in just a few minutes. Also, these three equations, your slope equation, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Your point slope equation, y minus y sub 1 equals m times x minus x sub 1. And of course, the slope-intercept form, y equals mx plus b. All of these are coming back, and we're going to work with them together. So let's just go ahead and get to the point of the matter. So this very first problem, it says, write in an equation of the line that passes through the given point and is parallel to the given line. Use a graphing calculator to check your answer. All right, so I'm gonna read it one more time. Write an equation of the line that passes through this given point, but it is parallel to this given line. All right, so how do we do that? Well, first off, let's look at it. We know what parallel means. Parallel means it has the same slope. So whatever the line is going to go through 1, 3 has the same slope of 2. So that's easy. So we know that the slope is going to be 2. We also know what our point is. We have a point of 1 and 3. Now that I know that, squeaky chair, sorry again, we're simply going to use our point slope form. Y minus y sub 1 equals m times x minus x sub 1, and we're going to plug things in. Y minus 3 equals 2 times x minus 1. Now we're going to simplify this side. There's nothing I can do with y minus 2 right now. Let's simplify this side. Hey, I can use distributive property. When I get y minus 3 equals 2 times x, which is 2x, minus 2 times 1, which is 2. So I'm kind of running out of room over here, so I'm going to bring it up. I have y minus 3 equals 2x minus 2. Well, my job now is to get rid of this y minus 3, the minus 3. How do I know that? Well, both sides are simplified as far as I can take it, so now I have to solve for y in SADMEP. Well, SADMEP tells me to do the opposite of a minus 3 and add 3 to both sides. Well, what happens when I do? I get that the 3's cancel out and leave me with y, and this gives me 2x, and -2 plus a positive 3 gives me a plus 1. So let's double check ourselves. And how do we do that? It says use a graphing calculator to check your answer. So let's do that right now. Turn my calculator on, clear things out. I'm going to go to y equals. So clear this out. I'm going to put my equation that I just created, 2x plus 1, in my calculator. I am going to hit graph, and it gives me this little thing. So I don't like this. This is something that I was using on the last time. So let's change our zoom. This just doesn't look all that great. So I'm going to hit zoom. And this time we're going to go to what's called Z standard. And Z standard sets the scale, sets the graph to where it's counting from 0 to 10. So these little hash marks, this would go from 0 to 10, this goes from 0 to -10, and this is 0 to 10, and this is 0 to -10. This is a standard graph. So this all looks a little bit nicer now. So we need to make sure that our equation is correct. So what I'm going to do is go to trace, and I know that if my equation is correct, if I plug 1 in, I should get 3. So I'm going to hit 1, hit enter, and I get 3. So it is correct. It is good. So what I want you to do for me right now is I want you to try problems 2, 3, and 4 on your own using the same thing. You're looking for a equation that is parallel to the equation you're given. And again, just let you know, notice how these two slopes are the same. Just giving you a little hint there. All right, so go ahead and try 2, 3, and 4 on your own. What you should have gotten was y equals negative 3x minus 8, y equals negative 3/5 x plus 4, and y equals negative 7/2 x plus 2. If you didn't get that or you don't know what you did wrong, you know how to find me. All right, so now let's look at number 5. It says write an equation of the line that passes through the given point, well, it's right here, and is parallel to the line shown. Okay, so we know we've got to write an equation that is parallel to this line. So the first thing I need to do is find out what this line, this parallel line is. So this makes things a little bit more difficult. So what we have to do is we need to find 2 points on this line that we know are on this line, and then we're going to find its slope. So the easiest one I see right here, here's a point, and that point is at 0, 2. So that's easy. And let's see if I can find another good one on the line. Looking. That looks like a possibility. Let me see. And here's a possibility. So let's use this one. This one seems really good. And that point happens to be 1 and 5. All right, so we have 2 things that we could possibly do here to find our slope. One is use our equation, which we know how to do, and that's what I'm going to do. And the other possible thing is just to simply count my slope. And this is, some of you have already figured this out. So let's look at my rise. So from this point to this point, I went up 1, 2, 3. So I went up 3, so that was a plus 3. And then to get from this point over here, I went to the right 1, so that would be a plus 1. Well, my rise happens to be 3, and my run happens to be 1, so I just found out that my slope is 3. If you don't like what I just did, why don't you do it the old-fashioned way and use the same equation, which is a whole lot nicer when you don't have a graph. So we can go m is equal to y sub 2. We're going to use this as y sub 2 this time. 2 minus 5 over 0 minus 1. And when I work this out, 2 minus 5 is negative 3. 0 minus 1 is negative 1. Solve for this. M is 3 again. So, hey, it still is correct. I either did it this way, which was quicker, or I could do it the algebraic way. Either way is fine, as long as you can back it up. Now that I know that, it's just a matter of plugging things in. I'm trying to find this guy right here, an equation for this point. So we're going to use our point slope form. Y minus y sub 1 equals m times x minus x sub 1. Let's plug numbers in. Y minus 2 equals my slope of 3 times x minus 1. Now I want to simplify this side. There's nothing I can do with this right now. Let's simplify this side. I can actually use the distributive property, and I can get that that's 3x, and then I can use this to get minus 3. So now that I've gotten both sides as simple as I can make it, now we can use SADMAP and solve for y. We want to get y by itself, so we need to get rid of this minus 2 by adding 2 to both sides. And I get that y is equal to 3x minus 1. All right, so this would be my equation. And that's it. So we can actually kind of prove that and just make sure it doesn't tell us to, but we can do it anyway by putting it into our calculator, graphing it, and it gives me a new graph. That was really weird, but that's okay. Let me make sure I put, oh, no wonder. I put it in the wrong number. Minus 1, Mr. Lewis, not 11. All right, so we put that in, we can trace it, and let's find out what happens when I put the number 1 into my calculator. It gives me 2, so it checks out. So my equation for this parallel line for this problem is y equals 3x minus 1. Why don't you try 6, 7, and 8 on your own? What you should have realized is because we were all basing our slope off of this, every last one of these has a slope of 3. And for number 6, your equation would have been 3x minus 5. For 7, you would have gotten 3x minus 9. And for 8, you would have gotten 3x plus 3. All right, so now comes something a little bit more difficult. All right, this one is asking you to find a line's equation that is perpendicular to this line. So this is something that I've talked about to several of you one-on-one. We haven't really made this assumption in the video, so we're going to make this statement now. If I know the slope of a line, in order for me to find its perpendicular slope, I need to identify its negative reciprocal. So let me explain what I'm saying. If I have a slope of 1/3, its negative reciprocal would happen to be 3/1, because this is the reciprocal, but then it's the negative reciprocal. Or we could simply say that the negative reciprocal of 1/3 is -3. But we can also do a different one. If I gave you a slope of -5/7, this guy's negative reciprocal would happen to be +7/5. Now, how do we know that these lines are parallel? Well, I mean not parallel, but perpendicular. Well, that's easy. We can double check. If this is correct, I can say 1/3, and I'm going to multiply it by -3. And if I've got this right, it should be -1. And it is. And since these slopes, when multiplied, equal -1, it tells me that these slopes are going to be perpendicular. And we can do the same thing with the -5/7. I can multiply that by the +7/5, and what I get is -1. So these are perpendicular. So the same concept happens here. I need to find the line that is perpendicular to this slope. Well, all I have to do is find the negative reciprocal. Well, the slope here is 1/2, so the negative reciprocal would be -2/1, or simply -2. Now that I know that, and I know my point, it's just a matter of using my point slope form. Y minus y1 equals m times x minus x1, and plugging things in. Y minus 1 equals a -2 times x minus 1. I need to simplify each side first. So basically, can I do anything else with this? No. Can I do anything else to this side? Yes, I can use distributive property. So -2 times x is -2x. -2 times a minus 1 gives me a +2. Make sure you catch that. -2 times -1 is +2. Now, what I can do, anything else to this side? No. But what I can do now is start sad mapping my y and solving for y by adding 1 on both sides. And when I do, I get that y is equal to -2x plus 3. Okay? So we already know for a fact that -2 and 1/2 should equal to -1. So let's double check it. So 1/2 times my slope that I said, -2, gives me -1. So that much we know is correct. The next piece I need to find out is, does this equation really work with this point? So we can plug it into it. Our calculator, -2x plus 3, we're going to graph it. Then wait for it just a second. Then we're going to hit trace, and we're going to plug our x value, which is 1, hit enter, and it finds out that y is also 1. So I have indeed found an equation. And if we want to, we can kind of do something else. We can actually put this equation in as well by saying 1/2 x plus 4, and if we graph it, you should see that it crosses. Now, our problem that we have is it doesn't look like a 90-degree angle. This is why we have to multiply the slopes. I can't eyeball this and say that this is a 90-degree angle, but I do know as a fact that if I multiply my two slopes, I am indeed getting two perpendicular lines. All right, so now that we've covered all that, my job for you is to try 10 and 11 and 12 on your own. Do that now. What you should have got for 10 was y equals negative 1/3 x plus 6. 11 is 1/2 x minus 7. And for 12, y equals 7/4 x plus 24. All right, so now 13 is pretty much the very same thing. Again, we're looking for a perpendicular line that goes through this. And so, in order for us to do that, to find that perpendicular line, we first need to know what is this slope. So I'm going to find 2 points that are easily identifiable that are on this line. And this looks like a good place. So this would be 0, 2. And this one looks like a good place, which would be 2, 2. All right. Did I do, whoops, not that. Nope, I didn't do that right. I knew that didn't. That's actually 0, 1. Sorry, I wasn't watching what I was doing. Now that I've done that, I can do one or two things. Let's go ahead and get in this habit. I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's plug some values in. I'm going to call this my 1s, and I'm going to call this, so this will be x1, this will be y1, this is x2, this is y2. So I'm going to go 2 minus 1 over 2 minus 0. M is equal to 1 over 2. So my slope is 1/2. Let's just double check myself. Notice that if I wanted to go this direction, I would go up 1, and to the right 1, 2, and my rise is 1, my run is 2. So indeed my slope is 1/2. But the problem wants me to find the perpendicular line, the perpendicular slope. Well, that's easy. Find the negative reciprocal. Well, actually, we did this in the very first problem, number 9. Go figure. The negative reciprocal of 1/2 happens to be negative 2. So now that we know what that is, it's just a matter of plugging everything into our equation, and I'll do it one more time with you. I actually was about to just finish out this problem for you, but I'm going to stop and I'm going to hide my work here. What I want you to do, you know what the slope is, and just so you can get some more practice on working with point slope form, why don't you go ahead and do 13 through 16 on your own. You know what the slope is. Just go ahead and solve for each of the equations and check your answers out when you get back. All right, so what you should have gotten for 13 was y is equal to negative 2x plus 4. Then for 14, y equals negative 2x minus 8. For number 15, y is equal to negative 2x. I think I said number 4 on that, didn't I? It doesn't matter. All right, so number 16, y is equal to negative 2x plus 6. All right, so guys, that's pretty much everything in a nutshell. No issues on that. And as always, you need me, come and find me. See you next time. Bye-bye.